everyone and welcome back to the Bodhi Academy. In today's video, we are going to solve the PYQs, that is previous year questions of chapter 9 Chemistry, Amines. So now in this chapter, we have a series of questions that are asked which are mostly based firstly on the reactions that we learned, as in the preparation of amines, that how they are prepared, those name reactions we have to know. Secondly, we need to know some of the reasoning related to their boiling points, melting points, all of this. And thirdly, we also need to know some of the chemical tests which are associated in this chapter. So to begin with, let's take down the first question. Arrange the following in the increasing order of their basic strength in aqueous solution. So we have CH3, NH2, then we have CH3 twice NH, and we have CH3 thrice N. So these are the three molecules that we have. So now talking about the basicity. Now in amines we should know that the basicity, it increases with the number of alkyl groups that are present. So over here if we see, this one has one alkyl group, this one has two alkyl groups, and this one has three alkyl groups. Based on this also we further classify them into, this becomes the primary amine, this becomes the secondary amine, and this becomes the tertiary amine. So as I said before, the basicity increases with the number of alkyl groups that are present. So technically in this case, this one should be most basic. But there is an exception here that occurs, okay? Technically this one should be most basic depending on the alkyl groups that are present, okay? But what is happening here is that we say that this is the one that is least basic. Now why is this one least basic, okay? As we see, we have nitrogen and we have three alkyl groups. So there is a bit of crowding that is happening in this case, okay, because we have three alkyl groups, okay. So this is the reason that there is some kind of hindrance that is being occurring over here. So therefore, due to this steric hindrance, we say that this primary amine which is there is the least basic. So over here the order will be, the least basic will be CH3 thrice N, then we will have CH3 twice NH, and last we will have CH3 NH2, where this is the least basic and the primary one is the most basic. So this was about their basic strengths. Moving to the next question, we have, why is aniline more stable than the anilinium ion? So now let's understand first what is aniline. So aniline is nothing but the benzene with NH2 on top, okay, and anilinium amine, that is anilinium ion, sorry, anilinium ion is NH3 plus and the benzene 3. So the question asked is, why is it that aniline is more stable than the anilinium ion that is present? Now let's look quickly at the resonating structures in both of the molecules that are present. So in this case, this nitrogen has a lone pair of electrons which will further participate into the resonating structures. So this lone pair will come down and this one will shift onto this carbon. So we get double bond NH2 and there's a negative charge here and these bonds remain same. Then what happens? This negative charge again moves over here and this one moves on to this carbon. So we get the next structure. Then again we move to this, and this one moves to this carbon. And last we get back our original one, wherein this goes here. Okay, so here we could see we have possible 1, 2, 3, 4 and 5 resonating structures that are occurring. Now same thing if we try into this aniline ion, what is going to happen over here is that this corresponding bond which is there will move here because this is electron deficient. So to fulfill that, this bond will move here and we will get double bond this is NH3 and there will be a positive charge over here. Okay, so now in this case if we see, okay, here there are only possibly 2 resonating structures that are present. So to define the stability of any molecule, what do we say is that the more the number of resonating structures, the more is the stability in the molecule. So in this case, clearly aniline has more number of resonating structures. So that is the reason it is more stable than aniline ion. And aniline ion in this state is highly unstable. So that is also a reason that this is a hypothetical thing that occurs. It does not usually occur because then in that case this nitrogen might occur a pentavalent state. Moving to the next question, we have how will you convert benzene amine to N-phenyl ethanamide. Okay, so we have to write over here a reaction that will yield us from benzenamide a N-phenyl ethanamide. Now N-phenyl ethanamide is also known as acetanilide. Okay, so it is also known as acetanilide. Now in this case, let's quickly write down a benzenamine structure, that is C6H5 NH. Okay, so we have a benzene amine over here. Now to yield N-phenyl ethanamide, we need another reacting molecule over here, and that is the ethanoic anhydride. So ethanoic anhydride, that is CH3C double bond O CH3O. C double bond O OCH3. So this is our ethanoic anhydride. So over here what we need is a amide group in the final product. So what is going to happen here? We will have C6H5, then N bond H, C double bond O and CH3. So here we have received our amide group that is present, that is we have NH and C double bond O. Also along with this we get CH3COOH as the byproduct. So over here benzenamine to N-phenyl ethanamide, we have benzenamine, we take it, then we react it with ethanoic anhydride, which in turn gives us this acetanilide, or also known as N-phenyl ethanamide and CH3COOH. Now this reaction, the name of this reaction is acylation reaction. Okay. In the next part, same, it is the continuation of the same question. We have another reaction, that is convert ethanamide to ethanamide. Now in this we have ethanamide over here, which has CH3, C double bond O, NH2. We have to reduce it to CH3, CH2, NH2. Now one common reducing agent that we know is that lithium aluminium hydride. So LiAlH4 is one reducing agent in the presence of water. So this reaction will further reduce this ethanamide which is there to ethanamine for us, using this lithium aluminium hydride as the reducing agent. Okay, moving to the next question. Write the names of the reaction associated with the following conversions. So we have two conversions here. First we have aliphatic primary amine to carbylamine, and second we have primary amide to primary amine. So we have to write the name of the reactions which are associated with this conversions. Now looking at the first one, we have aliphatic primary amine to carbylamine. Now we already know in this question itself we have a reaction which runs with this name, and the name of that reaction is carbylamine reaction. So in this reaction what is happening? We have a aliphatic or a aromatic primary amine which on heating with chloroform, that is CHCl3, in the presence of ethanolic potassium hydroxide, it forms either isocyanide or it forms this carbylamine that is present. So if we take a reaction, we have R NH2, that is our aliphatic primary amine, reacting with chloroform, that is CHCl3, plus it reacts with KOH. So this, all of these three things together yield us RNC on heating. So RNC is nothing but this carbylamine, or also known as the isocyanide. Now moving to the next one, primary amine to primary amine. So here there is a reduction that is happening. Now one reaction associated here is the Hoffman bromide degradation reaction. So in this case what is happening? R primary amide, that is R C double bond O NH2, okay, in the presence of bromine, that is Br2 plus a base, that is NaOH. It is getting reduced to RCH2 NH2. So this is the reaction of Hoffman bromide degradation reaction, wherein this primary amide which is there in the presence of bromine and NaOH is getting reduced to a primary amine. The next question, which of the two is more basic and why? Okay, so in this case we have to define from this, that is CH3 NH2 and aniline, which one is either more basic or which one is less basic. Okay, so now when we first look at NH2, now we have already done the resonating structures of aniline. So in this we know that the lone pair that is present on nitrogen, it participates in the resonating structures that are present. So here this conversion is occurring. So here what we can say that the lone pair which is present, okay, it is not available for donation. So the lone pair is not available for donation. Why is it not available? Because it is participating into the resonating structures. But if we look at CH3 NH2, 2. Over here, this lone pair which is there, it is open for donation. Open for donation as in it can form any further bond. So in this case, this is the reason we say, because this is not having any lone pair available for donation, we call this as one less basic, and CH3NH2 is more basic. Why is this one more basic? Because of the availability of the lone pair that is available for donation. Next question. Distinguish between the following by using a suitable chemical test. So here we have a pair of aniline and ethylamine. So in this case, we have to tell which one of them is going to show a change due to the chemical test. So one of the tests that we know is the azodie test. Okay, so now in this we need to know one important criteria, that is it only occurs in primary aromatic amines. Okay, so it should be firstly a aromatic amine and it should be in its primary state. Now if we look at aniline, okay, so in aniline we have NH2 and we have the benzene ring. So over here our criteria that it is firstly a primary molecule, secondly it is aromatic because there is a benzene ring, and thirdly it is a amine group. Now if we look at ethylamine, it is simply CH3NH2. So in this case what is happening, that there is no aromatic amine that is present, it is instead a aliphatic amine. So over here in this case the azodie test will only stain up this aniline. So it is easily, we are able to easily distinguish between the two, because only the aniline which is there, which is the primary aromatic amine, will show the azodie test. Moving to the next question. Give reason why primary amines have higher boiling point than the tertiary amines. So now let's quickly look at the tertiary amine. We have CH3 thrice N, primary amine, secondary amine CH3 twice NH, and primary amine CH3 NH2. So now in this, if we see, as the number of alkyl groups are increasing, okay, from here as the number of R groups are increasing, the hydrogens which are there are decreasing. The hydrogens associated with the nitrogen are getting decreased. So in the tertiary amine, if we see, we have no hydrogen bond donors that are present, because this nitrogen over here is lacking hydrogens. So that is the reason that there is no hydrogen bond donors. Now because of this tertiary amine which is there, it cannot form intermolecular hydrogen bonds, whereas primary and secondary amine both can form this intermolecular hydrogen bonds that are present. So this is the reason that tertiary amine is said to have a lower boiling point as compared to secondary amine and primary amines. Okay, moving to the next question, we have a multiple choice question over here. So we have, which of the following gives a dye test? And the options are aniline, methylamine, diphenylamine and ethylene amine. So before we move to the solution, if you all know the answers, please don't forget to drop it down into the comment section. If your answers are correct, we are going to give you all a like or a thumbs up to the comment that you all drop down. So now moving back to the solution of this, for a dye test, we have already discussed the most important thing is it should be a primary aromatic amine. So now let's quickly classify all of these options. So aniline, we have NH2 and the benzene Next we have methylamine, that is CH3NH2. Then we have diphenylamine. So in this we have NH. So here in diphenylamine we have two of the benzene rings that are attached to the nitrogen, and last we have ethylamine, that is CH3 CH2 NH2. Okay, so now let's look at each one of them. We'll start with ethylamine. So in this we need to know we need to have a primary aromatic amine. So now in this case we do not have over here a aromatic ring or a benzene ring. So in this case this cannot be the option because the aromatic part of the aromatic important part of the question is missing over here. Next we go to diphenylamine. So now in this we have the aromatic part, but if we see this over here, the nitrogen is having two of phenyl groups. Okay, that is the reason that this one also cannot undergo the dye test. Next, moving to methylamine, again it is not having the aromatic part to it, so therefore this also cannot be the option. So finally we have aniline that has the primary part, the aromatic part and the amine part itself. So to this one, aniline is the answer. Okay, moving to the next question, we have melting points are normally the highest for A. tertiary amine, B. primary amine, C. secondary amine and D. just for amines. So now in this let's look at their structures. So in tertiary amine we are going to have three of alkyl groups, the amide group and the nitrogen. Then for primary amide we have one of the alkyl group, the amide group and NH2. And for secondary we have two of alkyl groups, the amine group and the amino group. So now talking about the melting points. So if we look at the amide group, this is going to have the highest melting point. Now why is it so? If we look at the amide group, over there we have CH3, C double bond O and NH2. So here we see there is a strong bonding between the amide group and also the amino group. Okay, because of the presence of these two groups together in one, that is the amide group and the amino group, this primary amide is going to have the highest melting point. If we look at the other ones in tertiary, there is no amino group that is present. We directly have only NH. Even in the secondary one, we do not have the amide group, the amino group, sorry, we just have NH at the end. So this is the reason that the primary amides, due to the presence of the amide group and the amino group, are going to have the highest melting points. So that was it for today's video. I hope you have understood. If you have any questions, please don't forget to drop them down into the comment section. And thank you so much for watching today's video.